Hello lovelies, in this video we're going to go through the exact values for trig and how they can be used in your calculations. This is something you need to learn because it could go up as a really easy recall question right at the beginning of the paper, and that's just 3 marks.
We're going to have a look at trigonometry with exact values. Now, the exact values you need to know. Firstly, with trigonometry, we've always got sin, cos, and tan. And we have what we call exact values at 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now, if you remember kind of doing trigonometry, you press the buttons on your calculator. If you just press sin, cos, or tan and an angle, you're probably going to get some kind of horrible decimal number. By exact values, the first ones we can look at are whole numbers. Now, I've got the graphs at the bottom here, and if we look at the graph of sin x, we can see that at sin of 90, which I'm just marking on the graph here, we can see the red line of the sine graph goes through 1 at 90 degrees. So we can say at the sine of 90, we have an exact value, it's 1. And if you put sin 90 into your calculator, you're going to get 1. Other whole numbers, you might notice that 210, we can see that this is going through -1. And then there are 3 points where the sine graph goes through 0. At 0 itself, 180, and at 360. So we can say the sine of 0 is 0. So that's another exact value. Now you'll notice I've done some of these that are above 90 degrees, for example the 180, the 270, the 360. We'll talk about those a little bit later. I'm just going to concentrate on the first 90 degrees to start with. Looking at cos, we can identify some exact values here as well. So with 0, cos 90, the red line's going through 0, and at cos 270, it goes through 0. And then at cos 180, we can see the red line is going through -1. At +1, cos 0 is where the line is at +1, and cos 360 is where the line goes through +1 as well. Looking at zeros and ones with tan, we can see that tan 0 is 0, and we can see that at 45, the red line is going through 1. So tan 45 is 1 as well. Then with 0, we can see 180 and 360 are also 0. And then we can see that at 135, we're going through -1. At 225, we're going through +1. And at 315, we're going through -1 as well. These are the whole numbers you can find on a sin, cos, and tan graph. And again, typing these into your calculator will get you 0 or 1. Now, another easy exact value to find is when it goes through a half. So, for example, on the sine graph, a half will be exactly halfway between 0 and 1. We can see where the red curve goes through that, and that's corresponding to 30 degrees. So, sine 30 is a half. There are other halves. We've got a half over at 150, and then we've got negative halves as well. So, we've got a negative half at 210, and another negative half at 330. Looking for halves on a cos graph, that's again halfway in between 0 and 1. I'll make a little mark, and I can see the red line goes through here, which looks like it's at 60 degrees. So cos 60 would be a half as well. We'd also have cos 300 is going through a half, and then we have negative halves at 120 and a negative half at 240. Now, when we look for halves on a tan graph, if you look at exactly where the red curve is, we can see that if we look down to the x-axis, it's not actually going through at an exact point. Now, this graph is going up by 15 degrees each time, but that's not actually going to get us a whole number. And if we do inverse tan 0.5 on a calculator, I'm getting 26.56 degrees. So while we can get kind of a whole number out of a trigonometry, the degrees we need is not a whole number, so we don't call that an exact value. Now, there are other exact values. So, for example, sin 45 is an exact value. Now, if we look at sin 45, and we go up to the curve, and we come across, we can see we're getting some kind of point here in between 0.6 and 0.8. It doesn't seem like it's going to fall on an exact number. And in a way, it doesn't. And if we put this into a calculator, sin 45 will get us 0.707. And there's more decimal places after that. So it doesn't at first appear to be an exact value. However, after some work, mathematicians discovered that you can represent that decimal 0.707, and again more decimals after that. It can be represented as 1 over the square root of 2. Now, we call this an exact value because it's not being rounded. So we wrote this as a decimal because it appears to be an irrational decimal and the decimal places have gone forever. It's not possible to write it as a decimal. But because we can write it as a fraction like this, and it's exactly accurate for no rounding here to write it as a fraction, we can call it an exact value. Now, there are other values like this. So, for example, sin 60 is root 3 over 2. And these look really complicated, and you're going to have to remember them. And there isn't really a way to work them out easily. Cos 30 is also root 3 over 2. Cos 45 is also 1 over root 2. Now, sin and cos 45 being the same is because the two graphs are at the same place. So I've already drawn on where sin 45 is. I'll highlight that a bit further. And if we go over to the cos graph, you'll see that cos 45, the graph is in exactly the same place. And it goes down to 45 degrees. And then for tan also has some exact values written in this form. So tan 30 is 1 over root 3. Tan 60 is root 3. And then tan 90, it's not defined. And you can see on the tan graph, we have those dotted lines where the tan curve keeps approaching that dotted line as you get closer and closer to it, though it's never actually going to touch it. So we just say that's undefined. So if you put some work into memorizing these, then the questions don't really involve you doing any maths. So question 1 is sin 60. I'm looking at the little table that I drew. Sin 60 is root 3 over 2. And that's all we write. We don't write anything else. We don't do any maths here. We just have to remember the value. Tan 30 is 1 over root 3. And cos 60 is a half. Now, with sine 135, we see that's more than 90, and I've only written down the exact values between 0 and 90. Now, I did mention before that there are more exact values, and it's just because the nature of these graphs is that they kind of repeat the symmetrical every 90 degrees. You might have a negative version, you might have a reflection of it, but it's the same values over and over again every 90 degrees. Now, a way to find sin 135 is just to find on the graph where it is. So 135 is here, we're marking in blue, and we can see where the curve is. And all you do is you find where is the curve at the exact same place between 0 and 90. And we can see it's in the same place as it would be at 45 degrees. So we just write down that answer. So sin 45 is 1 over root 2. So if sin 45 is 1 over root 2, then sin 135 is 1 over root 2 because the points that the curve reached is exactly the same place. We can do the same thing with cos 330. So we find where 330 is, we find where the curve is for that, and we just find what the corresponding degrees is in between 0 and 90. And we can see it's the same height as it would be all the way over here, and that looks like it's at 30 degrees. So cos 30 is root 3 over 2. So cos 330 is also root 3 over 2. Now, although we have covered values above 90 degrees, the most common thing you're going to see in the exam is going to be the values in between 0 and 90. I can't say I remember seeing one that's above 90 degrees, but it's there just in case you need it. Now, the next step with exact values in trigonometry is to actually use them in calculations. Now, this is going to be exactly the same as trigonometry with remembering a SOHCAHTOA. It's going to be exactly the same method, but rather than using a calculator, these would be non-calculator questions. So, looking at question 1, we're going to follow through all the steps that you should know for trigonometry. If you can't remember them, go back and watch the video on finding missing sides in trigonometry. But we're going to label what we have. So we have the hypotenuse, 200 centimeters, and we have the adjacent, which has been labeled B, and that is what we're going to try and find. Now, the opposite doesn't have any labels. We're not looking for it. It's not a clue. So we don't really care about the opposite. So we're not going to be paying any attention to that. So we've got the opposite and we've got the hypotenuse. So looking at SOHCAHTOA, it's always helpful to write it down at the start. We can see that we've got A and H. This will be a car question. So I'm going to draw the formula triangle for car, and I'm just going to fill it in from left to right with C, A, and H, with the middle letter being raised above the rest. Now I'm going to cover up what we're looking for. We are looking for the adjacent. So if we cover up the adjacent, what we are left with is C and H. And if the two letters are next to each other, then it's going to be a multiplication. If they were above each other, it would be division, but that's not happened. So we're going to do cos times the hypotenuse. That is going to be cos 45 multiplied by the hypotenuse, which is 200. Now, at this point, you should be used to getting your calculator out, typing that in, and getting your answer. But this is going to be a non-calculated question, and instead, you've been thinking about your memory and the memorized exact values that you've got. And what you should be starting to memorize, if you've done enough work on the easy questions, is that cos 45 is the same as 1 over root 2, and that is being multiplied by 200. Now that still looks like quite a complicated calculation, but now we just use our fraction rules and our surd rules, and if you're multiplying a fraction by a whole number, that whole number is going to go on the numerator, so that our answer is going to be 200 over root 2. We can't actually divide it by root 2 because we don't have a calculator, so we'll leave that as our answer. Given that side is labelled with a B in the question, I'm just going to write B is equal to 200 over root 2. And then with our units, it's in centimetres, so we can put centimetres on the end. Moving on to question 2. Again, we're going to label the triangle. We have the adjacent next to both angles. We have the hypotenuse, longest side, and with the opposite the labelled angle 30. And there's no letter there, there's no number there, so we don't need that. So we only have A and H. So again, it's going to be another car question, and it's going to use exactly the same form of triangle we used last time. I will draw it, and again, I'd always suggest just draw it every single time, just to help you remember. C, A, H, and we're covering up what we're looking for. Like last time, we're looking for the adjacent, so we've got cos and the hypotenuse next to each other. It's going to be a multiplication question, and it's going to be cos of the angle 30 multiplied by the hypotenuse 200. So the same as the last question, but this time it's cos 30 instead of cos 45. And cos 30, you should be starting to remember, is root 3 over 2. If you can't remember it yet, don't worry, just have it written down on a piece of paper. Use that as you work through these questions, and the more practice you do, the closer you'll get to remembering your exact values. That's been multiplied by 200. So now we just have to work out our fractions. So multiplying a fraction by 200, it's going to go to the numerator. That'll give us 200 lots of root 3, and it's being divided by 2. So 200 root 3 divided by 2 is going to give us 100 lots of root 3. And again, that's B equals, find missing side B, and our units were in centimetres. Moving on to question 3. So again, we're going to label our triangle. We have the longest side is the hypotenuse, the side next to both angles is the adjacent, and the side opposite the labelled angle 60 is the opposite, which again, we have no values for. So with A and H, this will be another car question, C, A, H, and I think we're still looking for the adjacent. So we're going to cover up the adjacent. That gives us C and H next to each other. So we're going to multiply the cos, and it's cos of 60 this time, multiplied by the hypotenuse, which is 180. So cos 60 has an exact value, and that is a half. So we can swap cos 60 out for 1/2. We're going to multiply that by 180. And again, with a calculator, we'll use our fraction skills. So that would be 180 over 2. We multiply a fraction by a whole number. It's going to go on the numerator. So 180 divided by 2 is going to give us 90. So we've got a nice whole number this time. So missing side B is equal to 90 centimetres. And this is one of the good things about using exact values. Sometimes you get a nice whole number to an answer without actually having to use a calculator. Question 4, I'm going to label the triangle. the longest side is the hypotenuse, and there's no labels there, there's no numbers, there's no letter, we're not looking for it, so we're not going to be needing the hypotenuse. We do have the adjacent, and we do have the opposite. So with O and A, this is going to be a TOA question. Draw the triangle, put TOA in from left to right, T-O-A. We're going to cover up what we're looking for. Now we're looking for the opposite because that's a letter A there. So this is going to be a multiplication question. And all these medium questions are multiplication questions. We're going to do the tan, and it's going to be tan of 45 multiplied by the adjacent, which is 113. Now, the exact value of tan 45 is 1. And that's going to give us quite a nice and simple question here. So we're going to swap tan 45 with 1. We're going to multiply that by 113. And multiply number by itself, you just get the same number again. So we can just simply write 113 as our answer. So the missing side A is equal to 113 centimetres. And again, it's another example of that you can sometimes get a really, really nice answer. And so it might be worth remembering that if you are using trigonometry and it's tan 45, you do actually have an isosceles triangle, and two of the sides are going to be the same length. Now looking at question 5, we have the hypotenuse, the longest side. We have the adjacent, which is next to both the labelled angles. And there's nothing labelled there, so we don't need the adjacent. But the opposite is labelled with a letter A, so we're looking for that. We have O and H, so it's going to be a SOA question. Draw the pyramid for it, S-O-H, from left to right. And it's going to be another multiplication question because we're going to cover up the O, we're looking for that, which leaves us with S and H next to each other, which are being multiplied. So it's going to be sine 60 multiplied by the hypotenuse, 180. The exact value of sine 60 is root 3 over 2. There's going to be another one that's a little bit more complicated. We've already done a root 3 over 2 question because look at question 2. Cos 30 is also root 3 over 2. So we'll just use the method we used there. So we're multiplying it by 180. That will go onto the numerator. So we'll have 180 lots of root 3 divided by 2. 180 divided by 2 is 90. So it'll be 90 lots of root 3. Finally, it was side A we're finding, and it was written in centimetres. And there's our final answer. Before we move on, it's important to know the answer's not 90, it's not 90 centimetres, it's 90 lots of root 3. And using a calculator, if you did 90 multiplied by root 3 is about 1.7, so that's going to give you 155.9 altogether, rounding it. So the answer's not actually 90 centimetres, it's closer to 156 centimetres. Just keep in mind that we've got these thirds involved, there's another step of calculation to go before we get a nice whole number so we can measure it in real life. Moving on to the hard questions, we'll continue using the same method, so we'll label the triangle first. We have the hypotenuse, it's the longest side. We have the adjacent next to both labelled angles, and we have the opposite labelled angle 60, and we have nothing for that. So we only have A and H. Now again at the top of the page, just remind me, so car, toa, and A and H are in car, so I'm going to draw the triangle for car. Left to right, C, A, H. Then I need to cover up what I'm looking for. I'm looking for the hypotenuse because that's labelled with a C, so that's indicating I want to find that. Let's cover up the hypotenuse. That leaves us with A and C, and they're on top of each other, so it's going to be a division question. So we're going to have the adjacent 130 divided by the cos, and it's always cos of the angle, so it's cos of 60 degrees. Now again, we can use our exact values. We're not using a calculator, so we need to remember what cos 60 is, and cos 60 is a half. So we can swap it with a half. So we've got 130 divided by a half. Now we have somewhat of a problem here because we have kind of like a triple decker fraction here. We've got a numerator, 130, then the denominator has got its own numerator and denominator. So it's getting a little bit complicated. In this situation, what we're going to do is we're going to take the numerator, and rather than dividing it by another fraction, remember divisions are a kind of fraction anyway, so we've kind of got two sets of divisions, two sets of fractions. We're going to take the reciprocal of the denominator, and by reciprocal we're going to flip the fraction upside down. And since we're reversing the denominator, we need to reverse the sign as well. Instead of dividing by a half, we're going to multiply, and the reciprocal of a half is 2 over 1. So 130 over 1 over 2, really complicated, we don't want to do that. So find the reciprocal of the denominator. Rather than divide by it, we're going to multiply by it. So we've got the opposite sign, we've got the opposite of the fraction. So the two opposites are going to cancel out and their math is going to work. So 130 times 2 over 1, 130 times 2 is 260, and 260 divided by 1 is 260. So we've got our answer. The missing side C is equal to 260 centimetres. Moving on to question 2, we have the longest side, the hypotenuse, which we've got no values for, so we're not using that. We've got the adjacent and we've got the opposite. So without the hypotenuse, this must be a TOA question. It's the only one without a hypotenuse. So draw the triangle, TOA for TOA, and we are looking for the adjacent. So we'll cover up the adjacent, and we've got O over T, so it's going to be a division question. The opposite is 170, and we're dividing it by the tangent 45 degrees. Now, again, we can't type that into a calculator. We need to remember what tan 45 is, and tan 45, nice and easy, it's 1. We'll have 170 divided by 1, which we can do. 170 divided by 1 is 170. So the missing side, A, is equal to 170 centimetres. And again, we can see the value here of remembering some of these exact values because we can get some quite easy maths and it's actually faster doing this with mental arithmetic. As long as we can remember tan 45 than it is typing it all into a calculator. Now looking at question 3, we have the hypotenuse and the adjacent, and there's nothing labelled for the opposite. So we have A and H. So it's going to be another card question. Draw the pyramid. I know we've already got it for question 1, but drawing it every time will help me to remember SOHCAHTOA. We're looking for the hypotenuse, so it's going to be a division question. And all these hard questions are division questions. So we have the adjacent 127, and that's going to be divided by the cosine of 45 degrees. Cos 45 is 1 over root 2, so we're going to have 127 over 1 over root 2. So again, we've got one of these triple decker fractions, which we don't like, so we're going to transform it into a multiplication. And if you want to transform the fraction into multiplication, since we've got the opposite sign, we need the opposite of the denominator. So 1 over root 2 would become root 2 over 1. So 127 times root 2 is going to give us 127 lots of root 2. And dividing it by 1, it's just going to stay the same. So we have our final answer. The missing side C is equal to 127 lots of root 2 centimetres. Now for question 4, the longest side is the hypotenuse. There's nothing labelled there. And we've got the adjacent and the opposite. So it's going to be a tan question. So draw the pyramid for TOA, T-O-A. We know all these division questions. We're looking for the adjacent, so it's going to be the opposite divided by the tangent. The opposite is 100 centimetres. The tangent is going to be always about the angle, so 30 degrees. And tan 30, we should be remembering, is 1 over root 3. So we're going to have 100 over 1 over root 3. Again, one of those horrible triple-decker fractions. Let's get rid of it. So we'll turn it into a multiplication rather than a divide. That means that the fraction 1 over root 3 is flipping into root 3 over 1. 100 times root 3 is 100 root 3. Dividing by 1 is not going to change it. So we have our final answer, A is equal to 100 root 3 centimetres. Now looking at question 5, we have the hypotenuse, we have the opposite, and there's nothing labelled for the adjacent. So O and H, this is going to be a sign question. So we'll draw the pyramid for SOA, S-O-H. We're looking for the hypotenuse, so we have O over S. That's the opposite, 121, divided by the sine, always referring to the angle, so it'll be sine 60. And sine 60 is root 3 over 2. So I'm going to have 121 divided by root 3 divided by 2. Let's fix that fraction. Let's make it into a multiplication. 121 times by. We need to flip the fraction upside down. So root 3 over 2 becomes 2 over root 3. So 121 times 2 is going to give us 242. We need to divide it by root 3. So we'll write it as a fraction over root 3. And then there's nothing else we can do with a calculator. So we have to say that it's in centimetres and that it is side C that we found.
Ouch! This is why in some videos I have unexplained scratches.